on how the materials conduct heat. So I said that according to band theory, it states that in materials inside the substances, there are three regions. So I said the first region is the valence band, where the electrons normally are found. And I said that we also have another band, which is the conduction band. And that is where the materials have to be. The materials have to be in the conduction band for that kind of substance to conduct heat or to conduct electricity. But I say that between the valence band and the conduction band, there is what you call it as the forbidden gap. So there is a gap, a space between the valence band and the conduction band. And that gap is the one that is passed, that is crossed by the electrons from the valence band to the conduction band. So I was saying that for a material to conduct heat, the electrons have to jump from the valence band to the conduction band. Minus that material cannot conduct heat. So that was what we had. So I said that in conductors, this gap that you are talking of, like a forbidden gap, in conductors like metals, the gap is not there. The conduction band and the valence band, they overlap. So we have no forbidden gap in conductors, right? No forbidden gap in conductors. So the electrons are already in the conduction band. So that is why if we say if you increase the temperature of the conductors like metals, you are going to increase the resistance, right? So that is why metals, when you increase the temperature of metals, the resistor of metals also increases. So I talked about the resistance. Manena kuti mkati mwa substance mumakhala ma atom achikhalire. Tima atom ndi chani? Ma atom ndi ma small unit of matter. Matter ndi chani? Matter ndi substance yonse imene imakhala ndi mass. Kalikonse kamakhala ndi mass, komanso kakuzotenga space ndi matter. So mukapati kamakhala ndi mass, mutocheza chikupatsani ma grams or ma kilograms. Mweza muchika pa scale mucheza chimene chikulemera bwanji. That means has got mass. Space mutu chikazika pala pake chitenga space. So timanena kuti mukati mwa substances munja mumakhala ma atoms, tima smallest part of matter, timakhala normally. Neno mukaleka substance ija kuyilumikiza ku magetsi, ma charges ndi amene timati timachita magetsiwo, o ma electrons no magetsiwo ndiyo current yo. So current ikamayenda or ma charges akamayenda mu wire muja, right? Temperature ya chinthu chija, substance ngati yakwera ili high. If temperature is just too high, tima atom tija tamene muja tima mpaka vibrate kwambiri. They vibrate. Ndi vibration lija kukapabwera so ma current aja, ma charges achituka maja, akamapanga supasi muwaya momuja ma vibration amatoms amene akuyambika chifukwa cha temperature amachita block olo amakhala kuti akutseka akuletsa kuti ma charges asadutse. Ndekambaka zimenezo pamakhala pakuchitika resist ngati kuti pakukhangalira ma charges iwo akukanidwa kuti asadutse pakuchitika kupanga resist kukana. That's why you're calling it as resistors. Pamakhala pakuchitika resistors akukanitsija kuti adutse kamba kuti matumuziwa kupanga vibrate akuchita block. Ndi amafunsa nditulira kuti why is it that ma metals temperature mukachita less temperature ma metals resistance yake imakhala yokula. That's the explanation, right? However, I said kuti any insulators the gap ndi yayikulu. Forbidden gap ndi yayikulu. Gap between the valence band and the conduction band is just too big. Ndekambaka zimenezo ma electrons amalephera kudutse ajowe acheka valence band akafika ku conduction band muja amalephera chifukwa space yakula. Ndekambaka zimenezo ma insulators samapita conduct electricity. If you increase temperature of insulators, you end up burning the material. Umangoyatsa. So electrons cannot jump to the conduction band. So there are no charges available in the conduction band. So current cannot flow. Right? Examples are for malaba, ma plastic, osewa current simadutsa. Here is the diagram. A valence band, conduction band. So here I have Quranic as the forbidden gap. So just too much gap, just too big. The ikulu singa would say my electrons. And of course, we have Quranic as semiconductors. My semiconductor in kind of gap pakati pa valence band ndi conduction band ndiyo tsika pang'ono ndiyo chepa. Under specific conditions, ma semiconductor aja amatha conduct heat. Mukapanga less temperature ya ma semiconductors aja chifukwa gap yake ndiyo chepa, ma electrons amatha jump from the valence band kupita ku conduction band. Chifukwa gap yake ndiyo chepa apo amatha kudutsa ngati temperature ikakwera temperature. Low temperature samakwera. High temperature amatha kudutsa kupita kuti ku conduction band. Mpaka zimenezo ndekuti ma semiconductors at a certain point they can conduct electricity. Right? So the point is there is a small gap between the valence band and the conduction bands. So at low temperature there is no conduction, yes, because no movement of charges. But at high temperature electrons jump to the conduction band. So current can flow. So my examples of semiconductors that we'll talk about, because topic is semiconductors. So it's silicon and germanium. These are examples of semiconductors. Okay, so on the diagram here, valence band, conduction band, of course, yeah, low energy because yeah. Simple as that, okay? So topic now we will now start with what we call it as the semiconductors. Before we proceed, do you have any question? Yes, welcome to this major part of this topic, which is semiconductors. So as I said, semiconductors is the word from half conductors. So they are not conductors, they are not insulators. So sometimes they conduct heat. So they are halfway conductors, halfway semiconductors, depending on the condition. So which condition? No temperature. If there is no temperature, if the temperature is just low, these materials cannot conduct heat. But if the temperature is high, these materials can conduct heat. So we call them as semiconductors. Right? So a semiconductor, actually, by definition, it means it's a material that can conduct electricity sometimes, not always. Yeah, I like this. They conduct electricity sometimes. It means for them to conduct electricity, it means we are depending on the condition. So it is between a conductor and an insulator, as I said already, right? So examples, it's silicon and germanium. These are the most common semiconductors that we'll talk about. So yeah, no, of course we're going to talk about the structure of a semiconductor. Actually, not very much important, but we can talk of types of semiconductors that I want to talk about. Here, focus much here. So on the types of semiconductors, we'll talk about pure semiconductors and impure semiconductors. So pure semiconductors is also known as intrinsic semiconductor here. Right? So we have got pure semiconductor and an impure semiconductor. Right. So what is a pure semiconductor? Actually, tikamanda kuti a pure semiconductor, the point is that kind of semiconductor that can increase its electrical conductivity from within itself. I like that definition. The point is, if I say a pure semiconductor, the semiconductor imene ikozochita increase olo imene imakwanitsa kupanga kuti ikhale conductor olo ichite conduct magetsi, ichite conduct electricity, but payokha, without adding something in it. Payokha can increase its electrical conductivity. That's why it is called a pure semiconductor. Right? So payokha imakwanitsa kuchita increase its conductivity. Ikozochita conduct payokha from within itself. So it's that material that can increase its electrical conductivity from within itself. Or okay, it's a semiconductor that without any impurities. Yeah, of course it's important, but it's not very much important. What I like is that you should say a pure semiconductor is a material that increases its electrical conductivity from within itself. Ndikuti payokha imakwanitsa kuchita increase electrical conductivity. Zimveka?
Yeah.
Alright, so zimakhala bwanji tikamati part mwadya koma timanena kuti pure semiconductor tikuchita kuti pure chifukwa kuti payokha imakwanitsa kuchita increase conductivity yake. Ma semiconductors iwa kungwasiya apo okha sachita conduct heat. Koma tikapanga fulfill condition yawo, tikachita raise temperature yawo, amatachita conduct heat. Ne pompa alipo magulu pali pure, impure. Impure tikamati pure payokha osafunanso kuti tipangeko adekena kake kanchere, payokha imatopanga conduct electricity. Imachita increase conductivity yake payokha. Right? Payokha ichita increase conductivity yake zimatheka. Then zimakhala bwanji. How does a pure semiconductors are formed? Zimakhala bwanji zimakhale pure semiconductors. So the point is, an example of pure semiconductor imene ifewo timagwiritsa ntchito kwambiri ndi silicon. Zimveka? Silicon pa periodic table ali namba cha? Alright, so silicon Se is number 14, right? Per periodic table. So if you are to draw structure yake, amakanditenga ali kunja silicon. Nkanditenga tiwire 8 and 4, siyocho? 2, 8 and 4. So it means kunja amakanditenga kunja ndi 4 ndiri mukajambula structure ya silicon, right? If you draw a structure of silicon, it means you have 4, you have 1, 2, 3, 4, siyocho? Ndero ifewo tikanena kuti tikaende pure semiconductor, chamachitika silicon structure iyi imapanga form covalent bond ndi silicon ina. Mezi makhala bwanji? Zimakhala chonchi. Silicon uyu apanga bond ndi silicon inaso. Ndiye kuti chamachitika kuti the point is apeka alesi apeka take 4, okay? Tikuza kuti kunali ndi 4 naso 4 siyocho? Kunja osewo. Tikuza ali ndi 4 yuso 4. Right? Bale muli pesa koma? Tikuza kuti winayu ndi silicon of course. Kuma wali 4 uyusa ndi 4 take. Ndi apanga covalent bond. Uyapeka 4 take usapeka 4 take. So uyapeka koyamba kake uyapeka so kake so aka. Uyapeka so kake ka 4 ka number 2 unayesa peka so kake so aka. Right? Unayesa peka so kake so. Right, unayeso. Unayeso kake unayesa peka so kake. Pamoja kanganika 8 Lezi machitika akamanga bondi yocho pameze kuti unayuso pambo siliko linasa amazipanga so bondi winasa panga so bondi winasa panga so bondi so structure yungu chuluka structure ikutalika structure ndi silicon. The point is one silicon atom can form a covalent bond with another silicon atom. The other atom also forms another bond to other. Will also like a chain of silicon atoms. So let us consider the point as this one. Okay, silicon. Let's say we do more to 1, 2, 3, 4, 5, 6, 7, 8, right? Also the bank so usabanga bond kuzakeso. Usabanga bond kuyuso. Usabanga bond kuyuso. So amapita yochi panga yochi. Ngati chileya cha silicon dioxide. Ama cha silicon. Neno the point is what happens is that temperature ya ichichi ikapanga increase mukapanga raise temperature ya silicon structure iyi. The point is pamapeza kuti ka electron kamodzi kamapanga jump mu structure muja kupita mwina. Pale malipesa? Do you get the point? So suppose kuti izinga lyonchi tuli ndi silicon and other silicon, right? So ukudani tema electron ngati 1 2, 3, 4, 5, 6, 7, 8. So let's say uyu atom yapanga jump abwera uku ikabwera uku because of high temperature, right? So what happens is that because of high temperature ndekuti kamodzi amapanga jump bwera mstructure mwena mucha neka kachoka malawacha kama kamkhale kuti kasiyapo space imene kakalipo. So this one, this other electron has to come and jump to fill that gap, whereby leaving another space again. Then this one wants to move and then fill this gap, thereby leaving a space again. So that space we call it as a hole. A hole is a charge. Okay? A charge, it means that space. Charge pamene apa yabwera apa izapezera pamalomo ndi charge kuyenda. So the flow of charge in this structure ndi imene imachita kale current. So tikamanena kuti silicon, pure silicon, imapanga formed like that one, pure semiconductor makachoncho. So silicon amapanga form bond ndi silicon wina, amapanga form bond, temperature amapanga high, ndekuti ma charges amapanga kuyenda, they start moving, jumping. So they jump from one structure to the other, thereby leaving a space behind. That space is what we call as a hole, and it is a charge, positive charge. So the other electron also wants to jump to fill that gap, thereby leaving another space behind. So it goes like that. Then you can hold the charge. That's what we call as the pure semiconductor. So this is how I'm saying. You say, well, okay, a silicon atom. So each atom has got 4 valence electrons. So atoms come together to form a crystal structure. They form a bond. So each atom shares its 4 electrons with a neighbor. Okay? So you can be covered the bond being formed. So the point is, at low temperature, no electrons can move. At high temperature, some electrons can gain energy and break the free. So this creates a free electrons, charges. So current flow because of those charges. That's what we call it as the pure semiconductor. So tomorrow we'll talk about impure because it's just topic.